discuss about the types of mapping. Now, in my previous video, I told you about what mapping is. I told you about the conditions for mapping, and I also identified types of mapping for you. But in order to show the illustration of the types of mapping, I decided to break it down into the simplest form so that you people will understand what I'm talking about. Now, under the types of mapping, I already mentioned that we had six. So we are going to discuss on each of them singularly. Now, first of all, we have the one-to-one mapping, which is otherwise known as the injective mapping. So, so in this illustration, it said that any function of x is said to be injective if different elements in x maps to different elements in y. So in this particular case here, it can be illustrated in alphabet, it can be illustrated in numbers, it can also be illustrated in objects. Anyhow you pick the example to be. So in this particular case here, I illustrated it using alphabet and numbers mapping to each other, showing the relationship between two sets. And you know, in our normal English, we know what conjunction is. And conjunction is said to be a joining word, which we know in our primary levels. So in this particular case, it's trying to show the relationship between two sets. That if a function is said to be injective, if different elements in x maps to different elements in y. Showing the illustration here, A maps to 1, B maps to 2, C maps to 3, and D maps to 4. So in this case here, we have talked about the one-to-one mapping. Now the next one is the onto mapping. The onto mapping, a function is said to be surjective if every element of y has at least one element in x that maps with. So in this particular case here, what this particular function is trying to say that, you know, when you hear at least, it can be more than one. So in this case here, you can see in this element, A maps to 1, B maps to 2, C also maps to 2 and 3, while D also maps to 4. So in this case here, you can see that C maps to two different elements, which is 2 and 3. So in this particular case here, we have illustrated the essence of onto mapping in this particular example. So the next one now, we are going to talk about the constant mapping. Now I want to use real life scenario to it now. We know God created us and also the universe, and we describe God as the figure of 2 here, while everything he created is illustrated here. So in this case here, if you want to classify God here, we can describe it here as this: creating humans, creating technology, creating infrastructure, and creating knowledge. So in this particular case here, I've already illustrated the fact that constant mapping can be illustrated in just such simple things. Just classify it as when God is creating the universe and also mankind. So now, we now have the identity mapping. Identity mapping is just a simple type of mapping. So it's just trying to say that any element in X maps to the element in Y, showing that they are both the same. So in this particular case, you can see the letters here is also the same thing as the letters here. So it's called the identity mapping. That is, they have the same elements in X and also the same elements in Y. So here now we have the one-to-many mapping. In this particular case here, most of you are very conversant about quadratic equation, which you have done in your first year. Maybe in the first semester, they will have taught you about quadratic equation. So in this case here, you know that the multiples of 4, we have the multiples of 4, what are the products that can give you 4? We have 2 times 2. So in this case here, I'm trying to illustrate that 4 can not only be gotten by 2 times 2, it can also be gotten also in a negative way, which is minus 2 times minus 2. So in this case here, minus 2 times minus 2 will also give you 4, and 2 times 2 will also give you 4 too. This likewise 9 too. Minus 3 times minus 3 will give you 9, and 3 will also give you 3 times 3 will also give you 9. So we also have the one-to-one, many-to-one mapping. So a many-to-one mapping is the other way around. When I've already said one-to-many mapping, it's trying to say that one to multiples of elements, while multiples of elements to one in this second type of mapping here. So in this case here, it's just intertwined and it just change position. That the 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 domain here, in this case here, is producing the results here. So the codomain will become interchangeable to become many to one mapping. So the codomain will become the domain, while the domain will become the what? Codomain. So in this particular illustration I've given you so far, I hope you understand the various types of mapping. And also we also have what we call the bijective mapping. The bijective mapping is also the combination of the injective and the subjective mapping. So in further notice to that, you already know that one-to-one mapping is trying to show that if different elements in X maps to different elements in Y, and also if it is subjective, that if one element in Y has at least one element that maps to X. So in this case here, you already know that this particular element, the combination of the both of them can be otherwise. So if you see a particular question and they ask you to be what, if it is bijective, that means you already know, using the illustration of what I've already taught you so far. Bijective is the combination of this injective mapping and the onto mapping. So using that illustration, you can answer your question in a fast pace and get your correct answer. Thank you very much. God bless you. Please like, comment, subscribe, and share my channel to people that will find it difficult to understand these basic things. Thank you very much. God bless you. I really appreciate you. Oh, goodbye for now.